just a real quick follow-up to my previous video. I had laid out this PCB experimenting with maybe how do I get the different voltages I'm going to need, maybe better than the way I was doing it before with a series of LDO regulators. And instead in this specific PCB, I was leveraging this here, which is a quad switching regulator basically. Now, as I was experimenting with this, I was following one of the samples here in the documentation, and I'll scroll down to that here briefly. And one of the comments was, well, I probably don't need this MOSFET up here. This example that they're showing is for really over voltage type of protection, and that's probably not something I'm going to need to deal with. And I was just seeing that this was getting a little more complicated than I wanted it to be. So I went ahead and I stripped this out. So this MOSFET and the related components that went with it, I've basically taken out. And another comment in the discussion was, really pay attention to spacing and what's near, whether it's these inductors or any of the capacitors, other things that are in this design. And looking at this, try to really pay attention to that. And I was just very loosely looking at this graphic previously, which kind of shows how to start laying some of this out. But I wasn't following this real rigidly, so I made a comment that I probably would come back and I needed to keep working on this. And that's what I've done. I've gone from this design here, which at least got the components on the PCB, but based on people's feedback, I'm guessing I'm going to have issues if I try to have things this close. So I did do something much closer to the documentation, and now this is the version that I have. And so I'm going to call this the 0.02 version. And you will see I removed the MOSFET, so the MOSFET's gone. Here is this LT3504 quad regulator. And what you're going to see is I've actually set up all of these separate copper zones. I've set up the power plane. Really, it's just a signal layer with a bunch of planelets, I think is what I've seen some of you refer to it as, set up within it. But this is really close, and I'll just pull them up side by side for a second. So here's this where I'm currently at. And let me try to make this all viewable. And let me pull back up that documentation, and I'll pull this over to the right. And now you can kind of see both at the same time. But I've done a couple of things. I've found that if I am laying out all this copper, which I've done, it's really helpful to put net names on pretty much any of these connections so that I can quickly identify. And that's what I did. I did come in here and I'll come up to that regulator, and you'll see that I put a SW5 net name on this connection, and a Sky, and a PG, SS1, SS2, all of these over here, SW1, D1, FB1, all the way down. And that way when I am in designing the PCB, now I can just look at these pins and see that, okay, this is SW5, this is 2V5, SW2. And then, of course, I can click on these copper areas that I'm setting up, and I can see that, okay, that's SW2, and I've got that on the top layer. So I've got this copper region for SW2, and that matches, what this inductor should be connecting to right there. But I've gone through and really tried to configure this to match what you're seeing over here. And maybe I'll go to the 2D version for a second. And so I think this is pretty close and should be, I think, acceptable as far as the spacing, and is a significant improvement from version 0.01. So I moved the power connector up top. And let me just look at that. That might be a little on the edge, but that should be fine there. These actually aren't connections. This is just to solder it down. But then here I have that quad output regulator, and you can see just nice connections to each of these copper areas. I'm going from this copper ground area to the VIN, the voltage input. I have the capacitor connecting those two copper areas. You can see I've got my diodes over here spaced out nicely. And again, if I go back to the actual PCB and look at this, I can see that, each of these I've got set up. So this is my D2, this is my D4, here's my, let's see, D2, D4, here's my D3 and my D1. And so that's basically what I've got set up, or what I've got going on here. Interestingly, I did find that their documentation is wrong. Now, maybe I have an old version, which I seem to run into every once in a while, that I'm using an old version that DigiKey or someone pointed me to. But these over here are actually in the wrong order. So whoever put that documentation together mislabeled. This should say FB4, 1, 3, 2. They reversed these. But here's output 4, which should go to FB4. Output 1, if you follow this trace over, should be right here. So I noticed that when I was actually getting this all connected up together, but that's what you're going to see here is I've got my 5 volt, which for me is my 4 output. So that's out 4, here's my out. Then this would be my next one over is out 1. So 4, 1, and I can come back and look at these two. So 4, 1, 3, 2 is the order. Again, that's just opposite of what the documentation shows there. And I did double check the pinout, and the pinout and all of the documentation does show this order. So I think these are just mislabeled up here. And if I even trace this back visually, I can see out 4, they just mislabeled these. But anyways, this is really now set up to pretty much match that. So I've got these inductors across. This capacitor didn't seem to be needed in the version I'm working on. And when I say the version I'm working on, initially I had this over voltage version, which did have that capacitor. And now the one I'm working on is a simplified one up here, and they don't have that polarized or electrolytic capacitor. But all of these capacitors that I see here, I believe I've got accounted for in this design over here. So maybe I'll pull this back up full screen just for a second. And if I continue to look at this, you can see I moved the oscillator down. I'll maybe go to the 3D version for a second. But the oscillator I've moved down to here, bringing that clock in on one of the global pins. Much of this, on this lower right stayed the same. This all fit pretty well. The only difference from the documentation is they bring this out further and up. And I ended up cutting these at an angle here just to fit within this upper wedge that I had open. And I think that's perfectly fine as I'm going through and doing this. Now if I break this out, I can start to look at all the different layers. Maybe let me even take this out further. But I can kind of start to see that as I go through this, if I want to, and this view is kind of interesting because you can really split these layers apart and kind of work your way through them and see what all of these fills are going to look like, whether it's on my bottom, what am I doing for fill, or what am I doing on the top for fill, what am I doing for some of these in between layers. For example, this is a power layer that I've set up. Maybe another view though would be if I go over to the PCB itself, and I can go to the layers, and I'll just go to copper layers for a second, and maybe I'll hide everything here, and then just bring up, I'll start maybe with the top layer. So here's the top layer that I have, and if I click one of these, I can see that this is a 3.3 volts, so 3V3. Here's my 2V5, my 1V2, and my 5V0. And so then what I tried to do beyond that, there is an overall ground fill for anything that I didn't have specifically filled in. I also have some ground, obviously, in these areas. Then I also have a different layer, which instead of being on the top layer is a power layer. Now there is a plain old ground layer, and I guess on the ground layer, if I look at it, it is just that. It's one big ground plane. If I go back, I can pick this power layer, and show it. And so this I have, there's a voltage in, so I've got a section for that. I have my 3.3 volt, I have my 1.2 volt, I have a 5 volt. So pretty much this whole thing, I've pretty much filled in with something that tries to connect all the voltages that I need, especially from these outputs, like grabbing this output up here, 3.3 volt, and distributing it to some places that I need it. This up here would be like the, actually right up here is the 2.5 volt, which I really am not doing much with. So I'm just running a really thick trace down to get that into the FPGA for that programming feature, which I will probably never use. But then I can come down here and I can see that I'm getting the 1.2 output over to my FPGA. And then I can also see that I've got my 5 volt coming up here just so that I can light up an LED. I have a header for it, and I send that also out to some of the pins on this. And I do also have a 5 volt coming down here. Now that I just simply ran a thick trace, so there's somewhere in here a thick trace that does go up and connect in, which is probably plenty adequate for what I'm doing for this. But I work my way around, again, 3.3 volt, 1.2 volt. I should have everything covered that I need covered there. If I go to the bottom layer for a second, the bottom layer, I can come in here and see that pretty much I've filled it with a 1.2 voltage. So I guess as my stack up, if I go back to my layers and I'll just turn everything on, I'll go to my top side, but it's a 4-layer. I've got the bottom setup signal, top is signal, of course, and then the one that's my power plane, I actually have marked as a signal, so I can break it up into those sub pieces, and then I have a ground plane. And I think everything's connected up fairly well at this point. So again, like here's this 5 volt. You can just see I'm running a thick trace that runs around. So that's a 1.6 with a 0.9 drill hole that just gets me up to this output up here, which is a 5 volt. And then I also have then that other power layer that does bring up that 5 volt up to here also, so that I can show an LED and get it to this connector in addition to the connector down here. But this, I think, going back to comparing it with this documentation, it's probably not exactly precise, but it is pretty close, I think. And maybe one of you will catch something that I'm not seeing, but pretty much laid out. And like I said, really the only main deviation is I cut these at an angle, but I think I've got plenty of ground. So I've got ground here. These are all ground on the top layer, plus I've got these vias that are connecting those into the inner ground plane. And they note something like that on here. So anytime there's this little circle with an X, that's a via to local ground. Anytime it's a plus, it's a via to an underlying VIN. And that is why I ran that VIN underneath part of this, is for that functionality. Maybe taking this full screen again. I think that's really it. I did spread out the LEDs so they're not all nice together, but I just kind of put them where it was convenient to pull the power. So I have a 2.5 volt indicator, a 3.3, a 5. My 1.2 is down here. And then I also have a power good indicator right up here. And finally, I've got my C done, which I just tapped into and set it down here because there was a convenient space. Again, I was trying to really keep this up here clear, except for just what this was doing. So this ends up chewing up a pretty good amount of space. And so I'll probably order one like this, but I'm going to test some other approaches for these FPGAs as I continue to experiment. But if I go ahead and measure this real quick, I'm really taking from here to here. Maybe a little bit more space, give it a little cushion. So that's, half this board wide. It's a 50, 55, somewhere in there. And if I come down, let me just slide over a little bit, but that's all the way down here to 64. So I'm chewing up at least a third of the board, if not more, just for this power connector and getting my different rails set up. Again, this is a 100 by 100 board, so it still left me this down here for these connectors, and that all worked out pretty well. But I don't know if this is something I need to have in future projects, or I'll use this in some projects. I don't know. We'll see. Regardless, though, I want to probably order this up and just kind of test this and play with that and see what I learn from it. Again, can I make this work? I think I'm perfectly fine without the MOSFET. I'll find a different excuse to play with that at some point. But with this regulator, should have a cleaner power setup than what I had before. Maybe, I know some of you are running some smaller, simpler, single voltage output regulators, and maybe I'm better off just using a couple of those, 2 or 3 of those. And I was looking at a reference design where they're really just using a pair of them. They're bringing 5 volt into the board, and then they're creating the 2.5. No, they're creating a 1.2 and a 3.3, and then they're using a diode, I think, just to drop the voltage of the 3.3 down to a 2.5-ish type of voltage for that programming feature on the FPGA. So I could get away with just a couple of regulators, and really I just need to put in regulators that I can have the enable, whether they're the simple LDOs, which is probably not where I should be, but maybe some of these other simpler single channel regulators that I could be using that are more of these ICs. But anyways, that's all I wanted to share right now. Just kind of a quick update, and just showing that this is probably a much cleaner layout, and I would expect that this should follow the design guide or the documentation pretty well, and gets me all my voltages everywhere, and I've got everything fully routed. I can come back in here and just double check I haven't broken anything, but DRC is still clear, and this is still a $7 board, or set of 5 boards for $7 plus a couple dollars for shipping. So nothing has changed there. So this one I'm going to set off to the side for now until I get my other QFP 144 version in, and see if I can get that running, see what I learned from that. And then I will take that, and maybe I'll order this up soon, just for the fun of it. But I'll see what I learned from my QFP 144, and then if I do get this in, I could kind of maybe test some of this and make sure this is all working fine. And then I can decide, do I want to actually use this regulator going forward, or is this still more than I need, or not? I could compare it with some of your designs that maybe you're running some separate single voltage regulators. And I do know when I go back like to that QFP 144 version I'm using, let me go back to that just for a second. Let me get this pulled up. Again, that's this version here. I'm not taking up a lot of space for the power. It's really just this small section right here. And I think I could get a little bit better regulators that have the enable pin, and I could have just a little basic logic for that to cascade through, so that I do get the sequencing that I'm looking for. But I will experiment again with this, with the plain old LDOs and no sequencing, and see how that works. And then maybe if I do get this ordered up, I can see if A, it seems to work, and B, can I get the FPGA to work inside of this PCB. But thanks for all the really fast feedback and suggestions. Appreciate it. And I imagine there'll be more discussion on the previous posts, and then maybe we can continue it on this post too. Thanks.